Good morning, everyone. We hope you are safe and doing well. As you know, our session today will be an online session for precautions. Stay safe at home and let's focus on our session to make it more effective. Mrs. Sam Said speaks to the students of third prep in the Egyptian language school in Doha, Qatar. We study Unit 1 in the second third curriculum of science. Unit 1, Lesson 2, which is the rate of chemical reaction. My dear students, let me remind you that the rate of chemical reaction can be detected by the change in the concentration of reactants and products in unit time. My dear students, today we focus on the factors which may speed up the reaction or even slow it down. As you know, a chemical reaction includes breaking down the bonds between the reactant molecules and the formation of new bonds between the product's molecules. So, what may speed up or even slow down the rate of the chemical reaction? These are the factors which affect the rate of chemical reaction: the nature of the reactants, their concentration, the concentration of reactants, and the temperature of the reactants, and even using a chemical catalyst. If you remember, a catalyst can speed up the reaction or even slow it down. And today I start with the word nature. What does it mean when I say the nature of the reactants is one of the factors which may affect the speed of the reaction? When I say the nature, I mean the bond between the reactant molecules. And as you know, the bond may be an ionic bond or even a covalent bond. On the other side, we also study the surface area exposed to the reaction. So these are the factors affecting the rate or the speed of chemical reaction, the nature, the concentration, temperature, and catalyst. My dear students, the bond between the reactant molecules may be an ionic bond or covalent bond. An ionic bond is a bond between positive ion and negative ion, and these ions are small ions. They can be broken down easily. A positive ion and a negative ion can be dissolved in water easily, can be dissolved completely in water to speed up the reaction or to increase the rate of the chemical reaction. So the ionic compounds or the reaction between the ionic compounds is a fast reaction. Why? Because it takes place between ions. Ions can be broken down easily or dissolved easily in water. So the rate of chemical reaction is high rate, or the chemical reaction acts with a high speed in case of the ionic compounds. Same like NaCl. NaCl is a salt, and as you know, a salt consists of positive and negative. Positive ion and negative ion here, for our example, which is sodium chloride. In sodium chloride molecule, we have a positive sodium ion and a negative chlorine ion. The negative chlorine ion can be easily dissolved in water. The same for the sodium or the positive sodium ion, sorry. On the other side, we have a covalent compound. When I say a covalent compound, I mean this is a covalent bond. My dear students, let's take an example for a covalent compound. NO2 is nitrogen dioxide. If we break it down, for example, it will give N2. Nitrogen is a diatomic molecule, and oxygen is another diatomic molecule. These molecules are large enough to take a longer time to be dissolved in water. So, which is easier to be dissolved in water, the ionic compounds or the covalent compounds? I can hear your answers. The ionic ones can be easily dissolved in water because they are made of ions, and ions can be easily dissolved in water or they can dissociate in water. Dissociate means dissolve completely in water to increase the speed of the chemical reaction. Unlike the covalent compounds include large molecules, and these molecules are too large to be broken down easily. They take a longer time. So the speed of the reaction in case of covalent compounds is slow rate, or it takes a longer time. So most of the reactions of covalent compounds are slow because they take place between molecules. They are difficult to be ionized or to be dissolved in water. Question: the reaction between sodium chloride and silver nitrate, sodium chloride NaCl, and silver nitrate AgNO3 is from fast reactions. When I say fast reaction, I mean it takes shorter time comparing to many other reactions. Why? Because this reaction takes place between ions. And as you know, ions can be dissolved easily in water. Sodium and chlorine are two ions in sodium chloride. Silver and nitrate. Nitrate is an atomic group. This group is negative atomic group, while silver is a positive ion. So it takes place between ions, resulting from the dissociation or dissolving of each of them in water. And keep in mind, please, that ions can be dissolved easily in water. Ions can be dissolved more easily in water. They don't take a longer time to dissolve. That's why the rate of the chemical reaction in case of the ionic compounds is faster than it in case of the covalent compounds. Let's back to the nature of the reactants. The nature means the kind of chemical bonding, and the ionic bond or the ionic compounds can make fast reactions. The covalent compounds can make slow reactions. And now we study the surface area of the reactants exposed to the reaction. The surface area of the reactants exposed to the chemical reaction. I have a chemical reaction between A and B. These are the molecules of substance A, and these are the molecules of substance B. As we can see, the molecules of substance B are found in the form of large piece. This is a large piece. Only the outer surface of large piece or this large piece, only the outer surface can react with substance A. On the other side, here, we have the same substance A and substance B. But on the right side, as you see, substance B is found in powdery shape. We call it as powder or fillings or even turnings. They are very soft. They can easily be reacted with substance A. So the molecules of substance B in case of powder, this substance is in the form of powder. This is called powder. As a powder or as a filling or as a turning, they can be easily reacted with A. It's very soft. On the other side, only the outer surface can react with substance A. So let's discuss again. Which one of them can react faster? Substance B in the left side or substance B in the right side? For sure, your answer will be substance B in the right side because it's very soft. It's like powder or filling or turning. So the area exposed to the chemical reaction here is greater than the outer surface here, which is only exposed to the chemical reaction. So the surface area of the reactants exposed to the reaction can speed up the reaction or even slow it down. For the last time I say that, substance B in the left side is in the form of large piece. Only the outer surface can react with substance A, but the inner particles, I mean these particles, cannot get in touch with substance A. So the reaction will be slow reaction. Let's go to the right side. Substance B here is like fillings or turnings or powder. This powder can easily be in touch with substance A. So the rate of reaction on the right side between A and B is faster than it in the left side between the piece of B and substance A. Practical example to prove that the surface area of the reactants can affect the speed of chemical reaction. Here's iron as a metal element. Iron can substitute the hydrogen of acid, as we know. This is a simple substitution reaction. And the product in this case will be FeCl2, which is ferrous chloride, and H2, I mean hydrogen gas. The amount of hydrogen gas evolved in number one, I mean in case of the iron fillings, is great amount of gas. By the way, this is a gas. This gas is colorless, tasteless, and odorless. This gas is colorless, tasteless, and odorless. On the other side, this is the gas resulted from the reaction between the iron piece and hydrochloric acid. So the difference between 1 and 2 is in the form of the substance. The substance here is the iron piece. Only the outer surface can get in touch with the acid. Only the outer surface of this piece can react with the dilute or the dilute acid. On the other side, we have the iron in the form of powder or turnings or fillings. These fillings of iron or this powdery iron can easily be reacted with the acid. So the rate of chemical reaction in case of number one is greater than it in number two. So the amount of evolved gas here is greater than the amount of evolved gas here. I mean, is greater than the amount of evolved gas in case of using the iron piece. Little amount of gas is produced here. So can I say the amount of evolved gas is an indicator for the speed of the reaction? The one which produces more gas, it means that the reactants can react easily and faster. And the gas bubbles are indicator. دي مؤشر أو دي دليل على the speed of chemical reaction. This is in case of 1 and 2. So let's make a conclusion of what we have explained. The speed of the chemical reaction increases by increasing the surface area. In case of the iron filling, the iron fillings are soft, can be easily reacted with the dilute acid or any other substance. They can be easily reacted. They increase the rate of chemical reaction. But while using a piece of iron has its outer surface to react with the other substance, but the inner particles are not in touch with the substance that reacts with them. So the rate of reaction will be higher in the case of iron fillings, not in the case of iron piece. So the surface area exposed to the reaction increases to increase the speed of chemical reaction. And this is our conclusion. For this part, the question may be like, the speed of chemical reaction increases by increasing the surface area of the reactants exposed to the reaction. Why? Because the number of molecules exposed to the reaction increase, or due to increasing the number of molecules exposed to the reaction. Using nickel filling or using nickel fillings in hydrating oil instead of pieces, which is better, to use a piece of nickel or nickel fillings or powdery nickel For sure, your answer will be it's better to use the nickel fillings or the powdery nickel. Why? In hydrating oil. Why? Because the speed of the reaction. The speed of the reaction increases by increasing the surface area. And for sure, the surface area exposed to the reaction is greater in case of the fillings than it in the piece. Affecting the speed of chemical reaction is a concentration of the reactants. Here we have low concentration for the reactants and a high concentration. In case of the low concentration of the reactants, little number of collisions can take place between the two substances. While on the other side, if the reactants are more concentrated, it gives a chance for more collision. بيحصل تصادم أكتر ما بين المولكيولز بتاعت الرياكتنتس وده بيزود لي the speed of chemical reaction. So the speed of chemical reaction increases by increasing the concentration of the reactants due to the increasing the number of collisions between the reactant molecules. Here we have low rate of collision and here we have a high rate of collision. My dear students, let's explain it more. We have two cases. One of them is concentrated acid, another one is diluted acid. In case of the concentrated acid, there will be more molecules of hydrochloric acid. More molecules of hydrochloric acid will make more collisions between the particles of reagents or reactants. On the other side, in case of dilute acid, there will be less or smaller number of molecules. Smaller number of molecules will make some collisions, so the rate of the chemical reaction will decrease or the speed of the chemical reaction will decrease. So let's make a short summary. The amount of evolved gas while using concentrated acid is more than that in case of hydrochloric acid as diluted acid. The concentrated acid, الأسيد لما بيكون concentrated بيديني more hydrogen gas as we have explained before, but when the acid is diluted, it gives low number of gas bubbles. So the rate of reaction here, the rate of the reaction of magnesium ribbon with concentrated acid is faster than it in case of dilute hydrochloric acid. To read this question and try to think about the answer. The speed of the chemical reaction increases by increasing the concentration of reactants. My dear students, as we have explained, a higher concentration means a greater number of molecules. A greater number of molecules makes more probable collisions. So in case of the concentrated acid, there will be more molecules, more collisions, and a higher rate or higher speed of chemical reaction. While in case of dilute acid or dilute acid, there will be less number of molecules. In case of dilute acid, the number of molecules will be smaller, and the number of probable collisions will be smaller, and the rate of chemical reaction will be slower. So the answer for our question will be because by increasing the number of reactant molecules, the number of collisions between them increase, and for sure, the speed of the reaction will increase. And now we come to another factor which is very easy. We have a solution. We are going to heat the solution. The solution gains thermal energy. The kinetic energy of the particles will increase. They move faster. Moving faster make them collide more, make them make faster collisions. And faster collisions make the speed of the reaction is doubled or becomes a triple or 4 or 5 times greater than it in the cold water. So, as the solution gains thermal energy, the speed of its molecules will increase. I mean the kinetic energy. درسته الكلام ده قبل كده. في previous years you have studied it before. When the substance gains thermal energy or heat energy, the speed of its particles increases. And when the speed increases, there will be more collisions, and more collisions means higher rate or higher speed of chemical reaction. So, by increasing the temperature of the reactants, the speed of the molecules will increase, so the number of collisions between them will increase, so the speed of the reaction will increase. Here I have hot water and cold water, and we have a chemical substance. I'll say this substance is A. On the other beaker, we have the same substance, I mean substance A. The rate of the chemical reaction in case of the hot water will be greater than it in the cold water. Why? Because the speed of molecules in the hot water is greater than it in cold water. So the speed of the reaction increasing by increasing the temperature. Why? Because the increase in the temperature increases the number of probable collisions between the reactant molecules. As a substance gains thermal energy, its particles become faster. The collisions will be faster, or more collisions take place. The speed will be faster, or the speed or the rate will increase. Again, a hot substance like hot water has a higher thermal energy, higher kinetic energy, higher rate of collisions, and a higher speed of chemical reaction. Why do we use a fridge to preserve our food? In the fridge, for sure, we have a low temperature. And the low temperature in the fridge slows down the growth of bacterial cells, or it doesn't allow the bacterial cells to grow on the food that we eat. So it preserves the food. Why we preserve our food in the fridge? The low temperature in the fridge will slow down the speed of the chemical reaction which the bacteria makes in our food. In the low temperature, the bacteria cannot do fast reactions on our food. So the answer will be because the low temperature in the fridge slows down the speed of the chemical reactions which are made by bacteria, which cause the rot or the rotting or of our food. If we want to cook our food faster, what can I do? I use a higher or lower temperature. For sure, the higher temperature is used to cook our food faster because it increases the speed of the chemical reaction. So, if you want to cook the food faster, you have to increase its temperature. Why? Because the speed of the reaction of cooking food increases by increasing its temperature. My dear students, now we came to the end of our session today. Stay safe at home and send me all your questions after you watch the video. Your homework will be uploaded to your team's account. Please answer it and resend it to the text messages or the inbox in the team's account. I hope that you understand all what we have explained today. See you later in our school. Thank you so much for watching the video.